Welcome, this is Quadratic Functions, Algebra 2. This is Lesson 4. In this one we are converting quadratic functions to vertex form. So we're converting them to standard form. It says, how do you convert quadratic functions to vertex form? So evidently we're going to look at all the forms. Remember, I explained as an overview, we have 3 different forms. We're going to learn how to graph each form and how to convert to each form. So in this one, we are going from vertex form to standard form. First thing we do is we expand with that squared. So I would expect you to box or FOIL x minus 4, x minus 4. Okay? Now that you box or FOIL that, you would end up getting a negative 8x plus 8. Now we distribute this 2, so we get 2x squared. 2 times negative 8 is negative 16. Whoops. They've got the 8x still there. I'm sorry, I didn't see their format. They're just showing that they bring the 2 in and multiply it. So they're writing a 2 there to multiply by that, and a 2 there. So now they get 16x and 32. What we would have gotten up here had we multiplied. Oh, I'm sorry, I have that wrong. Off of my 4 times 4 is 16. Negative 4x plus negative 4x is 8x. My apologies. Okay. So now we combine these last 2 like terms. 32 and 3 is 35. And we have just converted from vertex form to standard form. Okay? So you would write f of x 2x squared minus 16x plus 35. Okay. Now they want to take you through this going back to vertex form. I highly suggest you watch my video on completing the square. If you were not in class, I will put it in here so that you make sure and get that. It's important that you can just see it. It's a real short video, but I want you to see it. In completing the square, I'm not going to build it here, but in completing the square, what we do is we take this x squared plus 6x and we separate it out. We're going to actually build the square with it. And if you build in your mind this x as the corner of your square, and you've got the 6's, you're going to split them on each side so that they come out this way. And then you can complete your square by putting numbers in there. Okay? So mathematically, what we discovered we're doing is when we split the 6 between the sides, we're dividing the 6 by 2, and then to build the square there, we're taking that answer and we're squaring it. I always write my notes right there so that I can see them easily. And then I come down and I fill that in right there. Now I also go up and I fill in what the total amount would be, so that I get it correct over here. 4 minus 9 would be negative 5. We have now converted from standard form to vertex form. So it's f of x equals x plus 3 squared minus 5. In part A, how does the value of a in the function in the vertex form compare with the value of a in the function of standard form? I don't know if you noticed, but the sign and the value of the a is always the same in both forms. Pretty cool. So you know on any form whether it's minimum or maximum. Okay. In part B, how could you check that you found the vertex form of the quadratic equation correctly? Well, let's think about this. If we have the standard form and we go over to the vertex form, we could always just go backwards and convert it from this, like how we did up here, to standard and see if we've got it. Describe how to complete the square for this quadratic expression. Remember, we're cutting this in half. Go to the film if you haven't visually seen how to complete a square. That would be 4. And then we'd say 4 squared would be 16. And that's how we complete the square. Graph the function by first writing it in vertex form. Then give the maximum, the minimum of the function, and identify its zeros. Okay, I am going to get everything set up for graphing. I want you to graph it and show me tomorrow. I will be asking students to go to the board and lead us through this, so it would be best if you came in and had me check over it if you're at all shy or anything. Now remember, we really do prefer to make mistakes, especially in front of each other, so that we can identify the most common errors and learn from those. So I appreciate it if you're struggling with it that you volunteer as well. In fact, that's my favorite. And I thank you guys for making this a really good class. So we write the function in vertex form. What we're going to do is we're going to separate this out so that we can complete the square here. We cut the 8 in half. Half of 8 is -4. -4 squared would be a positive 16. Since we add the 16 here, we subtract it here to keep it balanced so that we haven't changed anything in the front. Okay, this is a little bit different than what they showed. Oh no, they showed it just like that here. I just didn't think to tell you there. Sometimes I've seen it where they add the 16 here and they add it to this side with the f of x. This is a little bit nicer so you don't deal with both sides of the equation. Okay. Now I'm not sure what they want us to do right there. I would think they just want us to fill it in again. And here is where we take it down to the square and we tell what this root is there. It's a negative already, so it's a 4. And 12 minus 16 is -4. So there we have it in vertex form. Sketch the graph. The vertex should be +4, -4. That's your HK. 2 points to the left of the vertex are 2 and 3, and you'll have to plug in the values. Either plug them into the equation or look on your graph. 2 points to the right of the vertex, plug those in, look on the graph. Describe the function's properties. The minimum is, you should be able to look at this. Remember, if it's positive, it smiles, so it would be a minimum. And it's the k value. So bring your k value right here. The zeros are, look at your graph and see where it crosses the 0 axis. Okay, now we are given a standard form of a function, and we are asked to write it in vertex form. So the very first thing that we do is we take these first two. We can't build a square when our x squareds, our biggest pieces, are greater than just one square. Because we've got a rectangle, and no matter how many pieces we split up, we can't build it into a square. So the first thing that we do is we take these two, separate them out, and factor out to get that down to a positive x squared. So we factor out a -2, put it out front. It just comes right into the front there. And now we need to work on completing the square, the setup for it. So 6 divided by 2 would equal 3 squared. 3 squared. So that will be 9. Now I wanted you to make sure and note something. See how we have the -2 out front, so it's actually multiplying by the 9? We make sure we still have it as a minus, but after that we put whatever this number is right there to keep them equal. So we're subtracting it now, -2 times 9. Sometimes those signs get confusing for students. Now we come down to our square, which we can look back up there. It was 3. And we go ahead and we multiply this one out. 9 times -2 is -18. -16 minus a -18, two negatives, revert that to a positive. So negative 16 and a positive 18 is a positive 2. And we are in vertex form. Please go ahead and graph this. If you're not certain how to graph it, please go back to the previous videos. Lesson 2.3 covers that quite well. Okay, how do you keep the equation of a quadratic function balanced when completing the square? That's where I'm showing you up here that whatever you multiply and enter in here, you need to make sure and put the same amount here, subtracting it, because over here it's been added to the equation. That's always a plus in here, so we want to subtract it out here. Okay. In part B, why do you factor out negative 2 from the variable terms before completing the square? As I explained a few minutes ago in the video, it's important that you can visually see how to build that square. And if you can visually see that, then you know that your coefficient on the x squared has to be a 1. If you can't see that, please come in. We can do it real quick at lunch or before school, or even on a break between classes. It's a real fast thing, but it's so important that you see that. I did show it in another video, and I have done it in class. Why might the vertex form of a quadratic equation be more useful in some situations than the standard form? Well, we already know that the vertex form is very handy for seeing maximum heights, for seeing minimum heights, the axis of symmetry, and identifying where the vertex is. In context, it's always nice to be able to very quickly tell how high something is, like a tunnel or a bridge, or those kind of things. So vertex form is kind of a preferred form. Okay, let's go to this modeling equation. The function negative 16t squared plus 64t gives the height h in feet of a golf ball t seconds after it is hit. Okay. So first thing, this is our independent variable. Our independent variable always goes on the horizontal axis with the x. So when you see this, you know this is your input, that's your x value, and right here it said that's t seconds. So we want to write seconds on our graph, and we want to get these filled in. 2, 3, 4, 5. See, it's every 2 is 1. Okay? Now, it also says that the height h in feet of the golf ball. So we want to go height in feet. Okay? That's of a golf ball. Again, we can number. This is 8, 16, 24, 32, 40, 48, 56, 64, 72. Okay? Now it says write the function in vertex form. Well, we can see already that it would be nice when we're talking about the flight of this ball to be able to see how the arch of it goes. So first thing we do to get that t by itself, that t squared with a 1 as the coefficient, we divide by negative 16. So pull the negative 16 out to the front. Now we want to complete the square, so we take that negative 4, divide it by 2, we get negative 2 squared, negative 2 squared. They've already brought that negative 16 out here to be multiplied by it. So negative 2 squared would be 4. And here we can use it coming down here. It's negative 2 squared. It's going to have the minus in here in order to accommodate for that 4t. So a negative 2 times negative 2 would be a positive 4. Okay? So we don't need to change this at all. Negative 16 times 4 is negative 64. A negative and a negative make a positive 64. So there is our vertex form. That's our k value. Here's our h. Here's our a. Use symmetry to sketch a graph of the function and solve the problem. The vertex would be right here, 264. The point blank is on the graph. Let's see what it says. The ball has a height of 48 feet after 1 second. So after 1 second, we're going to be up here at 48. Use symmetry of the function's graph to determine the other time at which the ball will have a height of 48 feet. Okay, we know that our vertex is at 264. So you know that that's your line of symmetry. And remember, I say any point to any side of the line of symmetry can be reflected over, and that'll give you the answer to the question that they're asking. Okay? You can always check your answer by plugging it back into the equation. And please come to class ready to demonstrate that one for us. What is the maximum height that the ball reaches? How do you know? Again, this is going to be your vertex. It's going to be your maximum point. If you know the coordinates of the point to the left of the vertex of the graph of a quadratic function, how can you use symmetry to find the coordinates of another point on the graph? And again, that axis of symmetry is like a fold line. It's like back in kindergarten when you made the ink blotch and you folded the paper and it came out on the other side at exactly the same distance. That's how we do that. Okay, on this one, it says to graph each function by first writing it in vertex form and then give the maximum and minimum. So the very first thing that you'll need to do is give yourself some space and create a spot to complete your square at. Half of 6 will be 3. 3 squared is 9. So we have x minus, bring that sign down, 3 squared plus 9. And now we need to do minus 9. So this one comes out as x minus 3 squared. And now you can look at your h, your k is of 0 value, and now go ahead and graph that. All of these should be worked similarly. Remember, on some of these you'll have to divide before you go into the parentheses to get this factor off of the x squared. These two specifically, they will be like this example right here, example B. We will be doing these in class tomorrow, but in case you want to work ahead and just kind of look at what you're doing. And this page here, in fact, I may hold it and give it to you in class tomorrow. Thank you very much.